So in the previous session, I discussed about the matrix inverse, how the matrix inverse actually designed, the way it is calculated, and why the matrix inverse is required. One of the requirements is to find the solution of the system of equation, but there are other applications that I'm now, for the time being, I'm now skipping because you will not be able to understand. Okay, so my second question that I wanted to pose is this: if you how to write, okay, I'm writing it in this manner, how to write the algorithm, of the methodology of finding the matrix inverse. Okay, how to find the algorithm of the methodology of finding the matrix inverse. Can anyone help me to by saying what was the matrix that I considered? 1, 2, 2, -1, isn't it?
Yes, sir.
Okay, so that was the matrix.
Yes, sir.
Yeah, okay. So that was the matrix that I considered. So my question is how to write the algorithm of the methodology of finding the matrix inverse. What do I mean by the question that you must understand? First of all, let me show you something. You will find it very interesting. Okay, because so far I have probably I have been discussing the same old things that you have so far learned in school, and probably were thinking that what new I'm learning. So since you are actually enrolled in this computer science and engineering course, so you have to arouse interest in you, I have to show you something which is pretty much interesting. I'm going to show you a software by which I can find the matrix inverse. Then I'll again come back to this whiteboard and I will discuss what I want to discuss. So I'm stopping the share right now. Okay. Once I show you this software, then you will be able to understand that my question that I'm asking you. Okay. The software is called, I hope that you can see my screen. The software is called Maple 2015. So I am clicking this software and I'm opening it. Nowadays, nobody actually finds this matrix inverse. Okay, since you are doing the computer science and engineering course, nobody does the inverse kind of things using manual calculation. The softwares are available, mathematical packages are available that I must, as a teacher, must inform you about. Okay, so this is the portal of Maple 2015. So I am opening a new document here. First of all, what you have to write is that you have to write this command. This is the command that I'm writing. See what have I written? I have written with linear algebra. Linear algebra that you are going to learn in this particular semester. And I'm clicking on the enter button. Now this particular portal is activated. I want to find the matrix inverse. Okay, A1 is equal to 1. A1 is the name of my matrix. So you can write simply A, no problem with this. After writing A, I'm putting a colon and then an equal to sign. That means colon equal to means I'm defining the matrix. Now, here is the matrix from which I can input the matrix. So let us first input the zero field matrix. This is the zero field matrix. If I put a semicolon and click, the matrix 0, 0 will be read. But if I want to give the matrix that I worked with as an input, I have to manually type in the elements. Okay, so I'm putting here the matrix elements. This was this was the matrix. Okay, and now I'm putting enter. So this is the matrix that I have you are able to see in front of your screen. Now I'm selecting this output. I'm selecting this and clicking the right button of my mouse. Several options are coming. Out of these options, there is an option called standard operation. And from this standard operation, you can calculate the determinant, you can find the inverse, everything. Determinant was -5, so -5 is getting calculated. Inverse is this one, so inverse is getting calculated. So you see that very easily we can find the matrix inverse using the software Maple. Other softwares are available by which can be applied. Okay, it is just a matter of availability. Another thing that I want to say, is the following. I don't know whether I'll be able to show this to you right now or not. If someone tries to find the matrix inverse using online calculator, what does he see? Matrix inverse calculator online. What does he see? Let us try to find out. I don't know whether I'll be able to show you the thing that actually not this will I mean this was not the thing that I wanted to show. Probably this one. Yeah, matrix dimension. Okay, matrix dimension has a meaning. I don't know, probably yesterday one of the students uttered the word dimension. Okay, when I can recall that when I asked what is the difference between determinant and matrix, he said dimension. Okay, probably he has seen this word from here. Matrix dimension has a specific meaning in the linear algebra, which will be taught to you in due time. So matrix dimension means, for the time being, you can consider this to be size of the matrix. Okay, that's it. Actually, dimension is not the size of the matrix. Dimension has a broader concept. Right now, for the time being, to make the things simple, we can consider it to be the size of the matrix. Then I'm going to set the matrix. So what was my matrix? My matrix was 1, 2, 2, and -1. And I'm going to find the I'm going to insert the matrix. I don't know whether it is I'm correctly done it or not. Just a minute. 1, 2, 2, -1. Yeah. Now, matrix inverse has been found. Okay, and we have already seen that this particular matrix has been this inverse has already been obtained by us using the software also. If I want to show you the detailed calculation that they have done, then you will be seeing this kind of thing. Okay, you will not understand what is happening over here. You are not going to understand what is happening, because this thing that you can see in front of you, it is not known to you actually. Okay, no minors, no cofactors, no determinant have been applied. Okay, so how the question is, what is this that I'm seeing in front of my screen? Okay, I don't know whether you have ever seen this in online calculator or not. So this is the thing, and ultimately see somehow they have got this particular matrix. They have highlighted this portion. On the left hand side portion, they have written this. We do not know right now what is this, but on the right hand side portion that is known to us, this portion is our inverse that we obtained. So I showed you three different processes by which this inverse can be found using a software, by manual calculation, by online calculator. But the question is, what was my question? My question was how to write algorithm of methodology of finding the matrix inverse. The way we calculated the matrix inverse in our previous session, it is not the way by which the inverse of the matrix is found. Matrix inverse is found in a different way. Okay, someone has raised his hand. You want to say something?
यस सर सर जो अभी आप दिखाएं सर वो एनसीईआरटी में है ए इनवर्स निकालने का तरीका।
हाँ, क्या तरीका है बताओ
सर। गाउस एलिमिनेशन।
क्या तरीका है
उसमें
बताओ?
ट्रायल एंड एरर करके मेथड करके सर
Row
स्टेट वाइज
transform,
सेशन
column
इन्वर्स
transform.
निकाला जाता है
Row transform. What do you mean by row transformation and column
Using
transformation?
rank.
Using rank. Do you know about rank?
Yes, sir.
Okay, so
Little bit.
what is
Not
this?
much.
What is this? What we
Sir,
actually
the
bolo?
rank
Hmm.
ফার্স্ট লাইনটাকে নিয়ে
Hmm.
একটা এক্সট্রা লাইন অ্যাড করতে হয় তারপরে
আচ্ছা আচ্ছা মানে হ্যাঁ বুঝে গেছি আচ্ছা ঠিক আছে তো মানে ক্লিয়ার না ব্যাপারটা আর কি সো র্যাঙ্ক ইজ এ টপিক বাই
না খুব একটা ক্লিয়ার
খুব
না
একটা ক্লিয়ার
দেখেছি
আচ্ছা আচ্ছা what is the basic objective the rank the topic rank will be taught to you in the subject itself in far more details but right now I'm not going to discuss the details of this rank methodology but at least what is happening over here that I can say to you. What they do in this type of software or in this type of algorithm, they know that they have taken this matrix from the set M2 cross 2F. They know that this is the set from which the matrix has been chosen. And also they know that A inverse must come as identity matrix of order 2. Let us call it as I2. So what they do in this type of algorithm, they consider the matrix A, then they put a bar, and then they write I. Okay, what does it mean? Okay, first of all, let me show you what does this mean. And they put this inside a third bracket, sometimes first bracket. So what they are doing this thing, 1, 2, 2, -1, putting a bar on the side, and then on the right hand side, they're writing the identity matrix. This sort of matrix is called the augmented matrix. Augmented matrix. Augmented matrix, what do we mean by this word? Augmentation in matrix theory. In English literature, there are so many words which are synonymous to one another. Sometimes we call it addition, sometimes we call summation. Okay, addition, by when we use the word plus sign, then we call it addition. Okay, then when we use the term symbol like sigma, we call it summation. But addition is nothing but summation. Summation means you are adding the things. When we do the calculus, we call it integration. It is big elongated S is called summation, stands for summation. So all these things are equivalent and are applicable to different systems. Augmentation is also a kind of addition, but here the addition is not the way things are added. Augmentation means, I mean, say for example, suppose there are 2 rooms. I'm very from a pedagogical point of view, I'm saying 2 rooms containing several students are there. Students are sitting in room number A and room number 2, and between them there is a wall which actually divides the 2 rooms. If I break the wall, if I'm breaking the wall, the 2 rooms are becoming one singular entity. That is called the augmentation. I have to, in another sense, I have added, in my capacity, I have added many students together right now. If I join section, if I suppose the best example is the way I'm taking the class right now. A CSE section A student and CSE B students are, both of these students are actually attending the class. So this is an augmented version. After 1 or 2 days, a pillar will be raised in between them. They will divide the 2 sections separately. In one section will be called section A, another section will be section B. So that is just the opposite of augmentation. So this is the matrix which is the augmented matrix. Why? Because previously actually the order of the matrix is 2 by 2. Now the order of the matrix, if you see it as a whole, the order of the matrix now has become 2 by 4. As a whole, you can see it 2 by 4. And now what they do, the basic objective is that, what is the purpose? That I want to explain to you. What is the purpose of doing this augmentation? What is the purpose? The purpose is they want to apply some sort of row and column operation, some sort of row and column operation. Okay, row and or column operation. Either you can apply row operation or column operation, or you can apply both. But there is a punchline that I'm going to say later on. Such a way so that in this particular place here, in this particular place, the identity matrix I comes, and in this particular place, another matrix B comes. If you can bring, and this is the equivalent sign, because these two matrices will be characteristically equivalent. So if you can bring the system AI into system IB by doing row operation or column operation or any valid operation, by any valid operation, I actually mean if the row operation is required, then simply apply row operation. If column operation is applied, only apply column operation. Combination is actually not applied. Do it in such a manner so that you can bring this particular structure into this structure. If you can do so, if this can be done, if I can write AI is successfully taken into an equivalent form of IB, then we call A to be the inverse of B and B to be the inverse of A. B to be the inverse of A. Inverse of A. And the row operation and column operation by which this particular strategy is played, this method, one student has already named this method, which is called the rank method. So the software which I showed you and the online calculator that I showed you, in both the cases, the behind the screen algorithm that is running is the algorithm for rank method. They have not applied the determinant cofactor type of thing over there. They have written, because matrix can be easily input as arrays in the computer, and you can apply any language. C programming language is there, C++ is there, any language you can apply. Nowadays Python is also there. Python is a software which is actually, someone has raised his hand. Okay, Bolo.
Sir, if any matrix has a determinant of 0, then this method is applicable to find inverse. The inverse is not possible, but how can I find the inverse?
Okay, so no. The answer is no. Some absurdity. Suppose a particular matrix is there where determinant is actually 0. That means the determinant is 0 means the matrix is singular. Okay, and if you try to apply this method over there, the first and the foremost criteria of having inverse of a given matrix is that it has to be singular. I mean, no method like rank method or whatever, any method will not be applicable until and unless you justify that the matrix is. Please mute yourself. Please mute yourself. No method will be justified until and unless you are actually given a matrix which is non-singular matrix. For singular matrix, no inverse will exist. So your question is, if a singular matrix is there and if I apply this rank method, will the result come? No. The answer is something will come which is very absurd. Some absurdity will come and it will be reflected in the solution. Okay, we will automatically understand that this cannot be possible. Right now, since I'm not showing you the methodology, so I'm not able to, because I have to have some kind of, I have to show you first of all how this particular methodology is applied, and then you will be able to test by yourself what absurdity comes. You can test it by yourself, no problem. But answer is no. Singularity, non-singularity is the first and the foremost criteria for the existence of the inverse. Otherwise, no method will be applicable. Okay. If you apply this software to find the inverse of okay, two more people raised their hand. Let me see what they say. Okay, Go on. Anybody?
Sir,
Bolo.
can you repeat the augmentation part once more?
Augmentation part means matrix is what? Matrix always actually associated with a system of equation. So system of equation, many things are there. Variables are there, the coefficient to the variables are there. Right hand side, the thing that I wrote in the previous the slide is not there. So for example, x plus 2y equal to 1, y 2y plus minus x equal to 3. So you see this particular thing that I have written on the right hand side, this is called the requirement vector. Matrices are actually vector. You will gradually will understand, because matrix is a matter which is associated with the vector space. So matrix is also can considered to be a vector. Augmentation means you have a system originally, you are putting something else into the system, joining. You are not adding term by term, but you have 1 kg of sugar in one packet and another 1 kg of sugar in another packet. Now you are mixing the two packets together to make it a 2 kg of sugar. That is called the augmentation. That doesn't mean that each granules of the packet 1 and each granule of the packet 2, they are being clubbed together. They are conjoined together. Not like this. They are mixing. You are mixing them together. So that mixing, this kind of addition, is called the augmentation. So my original system was this, order 2 by 2. I am taking into consideration another matrix of order 2, that is the identity matrix, and I'm joining them. This vertical bar that I have used, this is the augmented. This is the thing that is actually showing that the system has been augmented together. That is called the augmentation. Now, if someone says that okay, what will happen for the non-singular matrix? So let's try to let me show you what the software is. Bolo.
তো এখানে যে রোয়ান কলাম অপারেশন গুলো লেখা হয়েছিল, ওখানে কি ধরনের অপারেশন করা যেতে পারে না করা হবে?
বলবো, সব বলবো, আস্তে আস্তে বলবো। সেগুলো তো আমাদের সাবজেক্ট ম্যাটার, সেই জন্য আমি এখনো বলছি না। সেগুলো তো আমাদের সাবজেক্টেই আমরা শিখবো, সব বলবো, ডোন্ট ওয়ারি। কি ধরনের অপারেশন করব সেটা হচ্ছে র্যাঙ্ক মেথড, সব আস্তে আস্তে বলবো। কিন্তু আগে আমি তোমাকে আজকে একটা বেসিক তোমাদেরকে একটা আইডিয়া দিচ্ছি, দ্য বেসিক ওভারভিউ অফ why the thing is being done. Our actual class has not yet started, so I am taking some time. The methodology will be described to you, don't worry. Now, suppose I'm taking a matrix. Remember that software that I'm actually using here behind the screen, that particular rank method, the algorithm for rank method has been written. Now, the particular student asked me what happens when the matrix is non-singular. So let's see. Suppose I'm taking a non-singular matrix like this. This is, and suppose this one is -1. So if I get write -1, and if I write it as 1, I think this is a non-singular matrix. -1 +1. Okay, now determinant is okay. If I select it, determinant, let us calculate determinant is 0. And if I try to find the inverse of the matrix, this error will come. See the error in linear algebra matrix inverse, they will give the outcome as singular matrix. Here behind the screen, the rank method is actually being applied. Okay, and by this they are trying to find out the inverse of the matrix. But as soon as you apply the singular matrix as input, the outcome will not be shown. If you try to do it manually, then some absurdity will come. Now, since I have some time, one of the students, he is very keen to know what sort of operation we actually perform over here. So let me try. I do not know whether I'll be able to finish this on time or not. So let me at least start the gear and tell you what is actually happening over here. So my matrix was 1, 2, 2, -1. I will perform the row operation and I will stick to row operation always. Remember, for some reason or other, why, do not ask me why am I sticking to row operation and not column operation, because that I am not going to explain right now, because otherwise in one single day the entire subject will be finished. Okay, so that is different issue. Later you would ask me at another time when I'll be discussing the core materials. I will perform the row operation in such a way so that in this particular system, here this place, this is the first place, this is called the pivot place. In this place, this is called the pivot place. Pivot means key element or pivot element. Here one comes, and below in the pivot place or key place, one comes, and below or above the pivot number 0 appears. Then we shift the to the RHS of the column, of the starting column, and diagonally to the pivot element, element 1, we try to bring the next pivot element 1, and as before, above and below this, we try to bring 0. I think you have not understood anything, but let me show you. This particular thing has been written from pedagogical point of view. Actual definition I have not, actual line by line process has not been mentioned. It will be mentioned in the class, but let me talk about a bit. This is my first pivot element that I have marked over here. Okay, let me write the augmented matrix, because I am working with the augmented matrix. So this, my augmented matrix is AI. So this is 1, 2, 2, -1, and put a vertical bar and put 0, 1, 0, 0, 1. Okay, now this particular element 1 is called the augmented pivot number. What is written in the first pivot place means this pivot place. First place means the first row 1, column 1 place. Try to bring the pivot number. Try to bring the pivot number as 1, but you see that it is already 1. Okay, so we don't have to do any type of operation over here. Okay, it is already 1. So okay, no problem with this. And below and or above the pivot number 0 appears. Now you see, if this is the pivot number, below it 2 is there. So we want to do some sort of operation over here, so that this 2 becomes 0. Okay, so what operation can be done? If I try to do the kind of operations, actually you see that no equality sign will be written, because these matrices are not equal matrices. These matrices are characteristically equivalent matrices. This is a separate term. So do not use any equality symbol over here. So what I'm going to do is that, since my first pivot number is already 1, this is my first pivot number, it is already 1. So keeping this intact, this row intact, what am I going to do is that I am going to this is my row 1, R1, and this is my row 2, R2. What I'm going to do is that I am going to subtract R2 of twice R1 from R2. I'm going to multiply it by 2, the entire row, and I'm going to subtract it from R2. So what do we get? 2 minus 2, that is 0. Here I'll get 4. So minus 1 minus 4, that is minus 5 will come. Here we'll get 2. So 0 minus 2, that is minus 2 will come. Here we'll get 2 into 0, that is 0. So 1 will come. So you see, in this place, 1, 0 has already come. My next part is to bring diagonally, means this one. I'm going to make this particular element to be 1. Okay. So this is the diagonal. This is my observation. I'm shifting my observation to the right hand side. So again, I'm choosing. Now, first of all, I have to keep the first row fixed. And then what I'm going to do is that to make this element 1, I can, what I can do, I can divide the row 2 by minus 5. Okay. I can divide the row 2 by minus 5. And after that, what I get, 0 by minus 5, that is 0, minus 5 by minus 5, that is 1, and minus 2 by minus 5, that is 2 by 5, and 1 by minus 5, that is this. So you see, 1, 0, 1 kind of structure has already come. Okay. Now, what is written over here? After getting the next pivot element 1, try to bring any element, if there is any, above or below it, to be 0. So my next objective is to make this element to be 0. Okay, this element to be 0. So I am again going to write the next equivalent matrix, and to make it 0, what I can do is that I can keep the second row fixed, 2 by 5 minus 1 by 5. This row 2 is fixed, but from R1, I am going to subtract twice R2. So if I multiply this second row by 2, so you will get 2 into 0, that is 0. So 1 minus 0, that is 1, no change. 2 into 1, that is 2, 2 minus 2, that is 0. Okay. And that will be 2 into 2, that is 4 by 5, that is 1 minus 4 by 5, that is 1 minus 4 by 5, that is minus 1 by 1 minus 4 by 5, that is 1 by 5. And this one will be 2 into 1 by 5, minus 2 by 5, that is 0 minus 2 by 5, that is 2 by 5. Now you see, I have to make these changes in such a manner. Suppose this is the first pivot number. I made it 1. It was already 1. And after that, I tried to make the second number to be 0 without changing the structure of the first number. It should not, the operation should not be of the kind so that once the requirement is fulfilled and you make the next change, the previous change must not be distorted. Once we get this particular column 1, 0 to be fixed, and you want to change anything to this column, you do it in a way so that this remain fixed. It should not be distorted. Once you get this particular structure 1, 0, 1, and you want to change this 2, do it in such a way so that this structure is not distorted. Ultimately, what we get? Ultimately, we get on the left hand side, we have got I. On the right hand side, we got a matrix B. And you see, this matrix is our actual matrix that we found by the determinant process, we found by the online calculator, we found by the software. And now we have found this particular thing by the rank method. So the student was very keen to know that what sort of row operation we actually perform. This is a very brief, discussion by which I am actually trying to say that this is the thing. This is very briefly. This is the thing that I actually you can actually do to get the matrix. Now the second question, another student actually a few minutes ago asked me what happens to the non-singular matrix. So I will ask him after the class ends. What he can do is that he can take this matrix. He can take another matrix, say A1, and you can consider this matrix -1, 1, 1. You know that this matrix is a singular matrix. try to form an augmented matrix of this form: -1, -1, 1, 1, 1, 0, 0, 1, and try to apply row operation and column operation to bring it into this form. Even if you know that it is not going to have an inverse, try to bring it and see by yourself what is happening over here, what sort of absurdity will come. This is a home task for you. Okay, so this is the thing that I wanted to discuss. You can write your student IDs in the chat box once again, because it is the second session. And with this mathematics, actually, we got actually 4 prerequisite classes for mathematics BSM 101. I don't think any more prerequisite classes will be given to us. Next thing is to start the actual syllabus, because we do not have time much and we have to finish the syllabus in due time. These are the things that I wanted to discuss with you, and you are going to see it in details, okay, in this particular course. And one more thing before I conclude my today's session, I will definitely send you a note on the prerequisite classes, on the topics of the prerequisite classes that I have taken. That other teacher who took the calculus section, he today sent me a book through WhatsApp. I'm going to share the book with you, and he has specifically mentioned that you are supposed to do a kind of a particular exercise from the book, from which a test will be conducted. In that particular question paper, from these discussions, inverse determinant properties, these things will also be there. But apart from this, that exercise the teacher is asking you to solve, from there he is also going to set the question paper. Okay, so I'm going to send you the book through WhatsApp. And Shubham Kumar has raised his hand. Time is not much. Tell me quickly.
सर सिर्फ एक चीज पूछना था सर, रैंक मेथड भी आ रहा है एग्जाम में?
नहीं, रैंक मेथड हमारा तो एकदम पूरा एकदम,
थैंक यू सर,
जो हमारा कोर्स करिकुलम है उसका पार्ट है। अब मेरा डिस्कशन जो था तुमको दिखाना कि क्या हो रहा है, मतलब क्या क्या कर सकते हैं हम मैट्रिक्स के साथ।
यस सर।
तो कोई एक
सर ये हम सबके 12th के बोर्ड के सिलेबस में है।
हाँ, तो अच्छा है, तो तुम लोगों को ज्यादा दिक्कत नहीं होगा। जिनके सिलेबस में नहीं है उनको दिक्कत होगा, इसलिए ये तो प्रीरिक्विजिट है, ये दोबारा से सिखाया जाएगा। और जो तुमको नहीं सिखाया गया 12th में, ये है कि मैट्रिक्स के साथ मतलब मैट्रिक्स के साथ ट्रांसफॉर्मेशन करके एक चीज आता है, लीनियर ट्रांसफॉर्मेशन। तो मैट्रिक्स के साथ उसका एक 1-to-1 कॉरेस्पॉन्डेंस रहता है। तो जो लीनियर ट्रांसफॉर्मेशन के बारे में मैं बोल रहा हूँ, ये वेक्टर स्पेस का पार्ट है। तो यू विल गेट टू सी इन मैट्रिक्स फ्रॉम ए डिफरेंट व्यू पॉइंट। So I am not going to set any question from this rank method. Students ने पूछा था, इसलिए मैंने जिसने पूछा था उसको मैंने इसलिए दिखाया, so that my discussion totally becomes a complete discussion. What is happening? What else we can do? But this is not the complete scenario. I mean, entire thing, all the pros and cons have not been discussed. Say, for example, I have not discussed what we mean by matrix dimension. Matrix dimension is not the same as matrix order. Order of the matrix is something else. Dimension of the matrix is something else. So we shall talk about these things later on when our actual class starts. So for now, I'm going to end my today's session. Hope you have enjoyed, and see you soon.
Please share the recording. Thank you, sir. Thank you, sir.
You, if you want to ask me any question, there is no much time left. I'm rejoining once again.
আমি আপনার গ্রুপে নেই।
তুমি ক্লাসে জয়েন করে আর
একটা যে গ্রুপ আছে অভিজিৎ স্যারের,
আচ্ছা তুমি
যে গ্রুপটা আছে,
শোনো তুমি ক্লাসে জয়েন করো। এই ক্লাসটাই আবার আমি জয়েন করছি, তুমি আবার ঢুকে প্রশ্ন করো। তোমার প্রশ্নের উত্তর দিতে দিতে তোমার ক্লাস শেষ হয়ে যাবে। আবার সেশনটাই জয়েন করো, জয়েন করে প্রশ্ন করো। আমি ঢুকছি আবার ক্লাসে সেশনে। জাস্ট এ মিনিট। একটু হোল্ড করো, আমি আবার ক্লাসে জয়েন করছি, তখন ঢুকে প্রশ্ন